there. I hope you're having a good day. And we're going to take a look at some circle measurement problems. So maybe your day will get even better if you like circles. But now is the time to go through and really kind of reinforce in your brain the different types of measurements that you can get with a circle. So you could find the circumference of a circle, which is exactly like perimeter, it's the distance around the outside of a circle. You could find the area of the circle, so everything that would fit inside the circle, or you could find the area of a sector. So in this case, this first problem you see here is the area of a sector. So we just want to know with this shaded in part, how many squares of whatever size, in this case, I guess miles, would fit inside that square or inside that sector. So with this, when you're finding the area of a sector, it's connected to the area of a circle. So the area of the entire circle is pi r squared. But if you take just a fraction of that circle, like we have here, for the sector, it's going to be the degrees over 360 times that pi r squared. So we have to have a fraction in our formula if we have just a fraction of the circle. Then once you have those parts, we'll go ahead and substitute in what we know and solve from there. So here we know the radius is 1, and so we can substitute 1 in for r squared. And then pi is going to stay pi because they want an exact answer. So that means we leave pi. And then finally, we've got this fraction out in front. What is x? X is the degree measure of that arc or of the central angle, as you might have talked about in an IXL, or if not, you'll talk about those coming up. So we went ahead and we set up our formula. If you wanted to, you could go ahead and grab a calculator. IXL here is starting us off with a pretty easy problem because 90 over 360 reduces to 1/4. And again, we want to leave pi in our answer. So I'm just going to say 1/4 pi, and then 1 squared is just plain 1. Anytime we've got numbers, we're going to multiply those numbers. So 1 times 1/4 is still 1/4. And so our answer is going to be 1/4 pi. So just remember, if you're calculating the area of the sector, you're going to take the area of a circle, multiply it times that fraction. Or if you want to just plain memorize the formula, go ahead and memorize that formula. Okay, so we've got our fraction 1/4 pi. There we go. First one done. Okay, now is when you have to pay attention because in this particular IXL, they are wanting you to pay attention to what is being asked for. If you were out in the real world, well, you are out in the real world, but if you had a specific job, say you were working in the grocery store at Walmart and doing pickup, and a customer asked for a bag of oranges, it wouldn't do to bring them a bag of apples. So you have to pay attention to what the customer asked for at the job. And here in IXL, you have to pay attention to what IXL is asking for. So quickly skimming through this problem, we have the diameter of the circle is 18 miles. What is the circumference? So we want to calculate the circumference. And there are actually 2 different ways that you could calculate the circumference. So there are 2 formulas. Possibly the more popular formula is circumference equals 2 pi r. We also have the formula circumference equals pi times the diameter. And take a moment, look at it. Which one do you think is more useful here? Awesome. I knew you would pick the second one because they gave us the diameter. So here they gave us the diameter. is 18 miles, so we can simply substitute that 18 for D, and we get the circumference equals 18 pi. If you'd wanted to go through and use the top circumference, that would work okay. It's just you would divide the diameter by 2 and then end up by multiplying by 2, and it cancels out. And so this second formula just saves you some steps. So it's 18 pi. That is not what I wanted. So 18 pi. Okay. There's another one all finished. Let's see what they give us next. What is the measure of arc EF? So arc EF, we're going to look at the measure, how many degrees this is. And remember, the measure of the arc is congruent to the measure of the corresponding central angle. But either way, with this, think about, what do you know about the measure of the entire circle? So if you go all the way around the circle, how much is that? I can hear you saying 360 degrees. That is correct. And so for this problem, we know 360 degrees, and we want to cross out the 130 or subtract that. We want to get rid of the 110, subtract that, and figure out what's left. So we're going to do 360 minus 130 minus 110. Sorry for the random noises. Sometimes when I'm thinking or finding things over here, I just make random noises. So maybe hopefully they're enjoyable. But when we go through and subtract, 0 minus 0 is still 0. 6 minus 3 is 3. 3 minus 1 is 2. And then 3 minus 1 is 2. 2 minus 1 is 1. So what's left is 120 degrees. And we can go ahead, write that in. And another one finished with a cheerful little sound to encourage us on. Now they're giving us a word problem. And with these, if you're not quite sure about word problems, it might help to start by drawing a picture. So it says the area of a circle. Hey, a circle is a shape. I'm going to draw a circle-looking shape. If you can draw a perfect circle, hats off to you. I wish I could draw a perfect circle. But here is my depiction of a circle, and we're told the area is 16 pi square miles. So I'm going to write off to the side over here. Area equals 16 pi miles squared, just so I know that. And then they want to know, what is the diameter? This is going to take a couple different steps, because they give us the area, and that's the entire part in the shaded, but we want to know, what is the diameter? And to go through and find that, we're going to actually start by using the area formula. So remember, the area of a circle is pi r squared, and this has the radius. So first step, we're going to calculate the radius and then use the radius to find the diameter. So if we know area equals pi r squared, and we know our area is 16 pi miles squared, we can say 16 pi equals pi r squared. And we want to get r by itself, so I go ahead, divide both sides by pi. A lovely thing happens because those pi's just plain cancel out. You don't even need a calculator for that. And then you get 16 equals r squared. What's the opposite of squared? Square root. So go ahead, square root both sides. And the square root of 16 is 4. If you want to be a really big smart aleck, you could say the square root of 16 is also -4, but does it make sense to have a radius of -4 miles? No, there is no such thing as -4 miles. Okay, now we found the radius. How are we going to use the radius to get the diameter? Well, as I'm sure you're saying right now, the diameter is 2 times the radius. So to get that diameter, it's 2 times the radius. So we'll do 2 times 4. So the diameter equals 8. There we go. Another one all finished up. This one, we've taken a look at one like this before, so I encourage you to maybe pause the video and go through and try and see if you can get this on correct on your own. I will pause the video as well and do the work, and so you can check that in just a second. Okay, you probably got that done pretty quickly, and hopefully you got the answer of 150 degrees. If not, pause the video, check out my work. But we'll go ahead and move on to the next one. So here is another one. It's got a couple of extra spaces, but it's exactly like that last one we did. Again, you're going to subtract everything from 360. So 360 minus 100 is 260, minus 60 is 200. 200 minus 70 is 130. So that gives us our answer of 130 degrees. Okay, we'll look at this, see if they give us any other weird kind of problems. Here, this one is, again, the arc measurement, so you would subtract it from 360. If you want to see an extra example of this, you can. Otherwise, you can go ahead and fast forward. Hopefully all my mental math is correct. We'll see that in just a second. Hurrah! So last chance to see if they give us something weird. Okay, they did give us something a little bit weird. And this is kind of the problem I was going through and looking for, because it takes a couple of different steps. We want to connect the area, the space inside that circle, to the circumference, which is the distance around the outside of the circle. And to connect those, we're going to need to know, what is the radius? So the radius is going to connect the area and circumference. I will start to solve this problem with what I know. So I know the area, and the formula for area is area equals pi r squared. So I'm going to substitute this that I know in. So I'm going to say 9 pi equals pi r squared, and this is a 2, just in case you couldn't read it. Go through and solve for r. The pi's cancel out, and you get 9 equals r squared. Go ahead and square root both sides, and r equals 3. So now that we found the radius, that's our connector, but we're not done yet because we want to calculate the circumference. What's the formula for circumference? Well, there are two of them. There's c equals 2 pi r, or c equals pi d. And in this case, I'm going to pick the top equation because it uses the radius. So I know that radius, and because I know the radius, I'm going to use the formula with radius in it. So we have c equals 2 pi, and our radius is 3. Go ahead and multiply any number. So 2 times 3 is 6. Keep the pi because they still want it in exact form. So our answer is going to be c equals 6 pi. Hopefully that helps you out. If you've got questions on any of these, please shoot me an email.